A new generation of radar and vertical launch systems has quietly been installed aboard the Bisheng test ship. Do these seemingly routine tests truly signal that China's 20,000-ton class warships are about to transition from blueprints to the open seas? In recent months, military observers both domestically and internationally have focused their attention on the Chinese Navy's Bisheng comprehensive test vessel. This seemingly unremarkable 5,000-ton ship has suddenly been outfitted with a new generation of radar systems and vertical launch units, commencing intensive testing. Understanding Bisheng's unique role in China's naval history reveals this is no ordinary equipment upgrade. It often signals that the framework for the Navy's next-generation main battle vessels has largely been established. The long-rumored 20,000-ton behemoth and 9,000-ton multi-purpose destroyers may no longer be distant dreams. Since entering service in 1997, the Bisheng has consistently carried out the special mission of testing new weapons, systems, and electronic equipment for the Chinese Navy. Named after the ancient Chinese inventor Bisheng, this comprehensive test ship, though not directly involved in combat missions, has spent years battling in the smoke-filled seas of the maritime battlefield, enduring the roar of naval guns, the flames of missiles, and the challenges of mysterious electromagnetic environments. It serves as an indispensable incubator in the development of China's naval forces. Virtually all new equipment destined for main battle vessels undergoes comprehensive testing aboard the Bisheng before entering mass service. From the 346 series phased array radar in the early 21st century to the circular vertical launch systems, VLS, later deployed on Type 052C destroyers, and the square VLS systems on Type 054 frigates, every system has made its way into combat service via the Bisheng. Consequently, when the new generation of radar and vertical launch units appeared on the Bisheng ship, keen observers immediately recognized that China's next-generation naval vessels had lifted a corner of their veil of secrecy. The testing of the new radar system is particularly noteworthy. Images circulating online reveal that the phased array radar array on the new destroyer is noticeably smaller than that of the Type 055 destroyer, likely indicating the adoption of an entirely new generation of radar technology. Meanwhile, a concrete bridge model spanning 26 meters in width sparked heated discussion in Google Earth imagery. This dimension far exceeds existing destroyer designs, surpassing the Type 055's bridge width by approximately 6 meters and narrowing by just over 2 meters compared to Russia's 24,000-ton Kirov-class cruisers. Such an expansive bridge structure strongly suggests that a massive warship, potentially displacing 20,000 tons, has entered the engineering development phase. Experts analyze that the future 9,000-ton multi-purpose destroyer may innovatively adopt a three-sided shield radar design, breaking from the traditional four-sided layout. This configuration would achieve omnidirectional coverage through a three-array combination while significantly reducing costs and increasing radar array size. The testing of vertical launch systems also signals a major transformation in Chinese naval armaments. Currently, the large-diameter VLS units used on Type 055 and Type 052D destroyers demonstrate exceptional compatibility, capable of loading various missile types and ranking among the world's most advanced. However, the VLS system deployed on Type 054 frigates is notably limited, capable only of launching HQ-16 series air defense missiles and U-8 rocket-assisted anti-submarine torpedoes. This compatibility limitation has become increasingly apparent since the 2020s, emerging as a bottleneck constraining the frigate's operational capabilities. The new generation VLS unit tested on the Bisheng frigate is almost certainly aimed at addressing this issue, creating a more versatile launch system. This is corroborated by the development history of the Type 054B frigate. The two Type 054B frigates launched in 2023 have now entered service, but surprisingly, subsequent construction appears to have been suspended. This situation mirrors that of the two Type 054 frigates built 2 decades ago, which also served as testbeds and transitional vessels. Evidently, the Navy is not entirely satisfied with the current version of the Type 054B, particularly regarding its propulsion system and VLS. Future variants, such as an upgraded Type 054B or a new Type 054C frigate, are likely to adopt diesel-electric hybrid propulsion and a next-generation vertical launch system. Looking back at the development journey of the Bisheng ship, we can clearly trace the evolution of China's naval equipment. As the Navy's first dedicated weapons system test vessel, it has quietly undertaken the testing and qualification of new naval weaponry. From the testing and standardization of weapons, like the YJ-62, HQ-9, and HQ-16, to the recent elevation of its vertical launch platform to test new VLS systems, the Bisheng has consistently served as both a witness and a driving force behind the advancement of China's naval weaponry. Its modular design allows for the easy removal and installation of various weapon systems, making it exceptionally well suited for diverse testing scenarios. This flexibility enables the Bisheng to test multiple weapon configurations on a single platform, providing invaluable data support for the Chinese Navy in selecting optimal equipment combinations. The development of destroyers in the Chinese Navy has formed a clear high-low mix pattern. The Type 055 heavy destroyer, serving as the high-end flagship, has a full load displacement exceeding 12,000 tons and is equipped with 112 vertical launch cells, possessing formidable regional air defense, anti-ship, and anti-submarine capabilities. The Type 052D series excels in flexibility and cost-effectiveness, making it suitable for mass production and diverse missions. Within this framework, the emergence of the 9,000-ton class destroyer will fill gaps in the existing combat capability system, striking an optimal balance between firepower and cost. The cost of one Type 055 destroyer could fund the construction of 2.5 Type 052Ds, while the 9,000-ton class destroyer strikes a balance between performance and cost, positioning itself as a versatile asset for future carrier strike groups. This displacement is no arbitrary choice. The U.S. Navy's Arleigh-Burke-class destroyers, exemplifying the 9,000-ton class, stand as a model with over 70 vessels built, forming the backbone of America's global naval power. For the Chinese Navy to venture into the deep blue, it similarly requires such a versatile vessel capable of both distant sea operations and mass production. In stark contrast to certain major powers, China has established a highly sophisticated industrial system, where all subsystems can be domestically produced. In recent years, however, the industrial capabilities of some major powers have severely declined. One cannot mass-produce gas turbines, and even needs to import them, and others Constellation-class frigates face repeated delays. China's shipyards have mastered advanced technologies like prefabricated sections and laser cutting. Dalian shipyard can even simultaneously build 4 Type 055 destroyers. Once the 9,000-ton destroyer project commences, multiple production lines at Jiangnan and Dalian shipyards can operate at full capacity, achieving an annual production rate of 4 to 5 vessels. This formidable shipbuilding capability lays a solid foundation for the rapid development of the Chinese Navy. With the commissioning of new generation flagship vessels like the Fujian-class aircraft carrier, the PLA Navy's blue water combat capabilities are undergoing a qualitative transformation. The carrier's new electromagnetic catapult system enables aircraft to take off with heavier weapon and fuel loads, allowing them to strike enemy targets at greater distances, and granting the Navy true blue water operational capacity. The emergence of 9,000-ton destroyers, or even larger 20,000-ton vessels, will fill the final gap in the existing combat system, granting the Chinese Navy true global deployment capabilities. That 25-meter wide bridge model may merely be a microcosm of this grand journey. As it transitions from the testing ground to the shipyard, the Chinese Navy's transformation will once again redefine the world's perception. Looking back at the development of the Chinese Navy, from the vantage point of 2025, it is clear that a nation's comprehensive industrial capabilities form the bedrock of its defense development. From the legendary 120,000-ton warship to various destroyers and frigates, new types of naval vessels and submarines are expected to emerge in succession. The next-generation radar and vertical launch systems tested aboard the Bisheng are pioneers of this grand journey. They represent not only technological advancement, but also symbolize the strategic transformation of the Chinese Navy, from near-shore defense to blue water operations. As these systems complete testing and enter mass production, the Chinese Navy's dream of dominating the deep blue seas is steadily becoming a reality.